So it's back to criticising this video lecture, Introduction to Relativity, by Dr. Mike Young. Dr. Mike Young is here on his website. He's Professor of Physics and he's at the Santa Barbara City College. And it's bad enough criticising Einstein's relativity. You find lots of people who want to believe in Einstein's relativity regardless of how many mistakes you point out with it. You've got these people who actually believe in Einstein's relativity and they contradict each other. So I've got this professor here in this video talk, and he's just about to say things and it's going to be in contradiction to what this professor is saying here. This professor is Richard Wolfson, who's from Midbury College, and what he says about Einstein's relativity contradicts what Mike Young says. So they don't even properly agree about Einstein's relativity. These people who believe in Einstein's relativity, they contradict themselves. And what you find is that Einstein has messed up things with time and so forth, and so when these people talk, they're talking from messing up things even more. So we go back to his talk. This is where he's just finished talking about the twin paradox, and if we go to this website, this is an open letter to the physics community to give a definitive solution to the twin paradox, because when you look into it, all these different people who believe in Einstein's relativity don't give the same answer. They give conflicting answers as to what is the solution to the twin paradox. And so that is one of the big flaws with Einstein's relativity. People believe in different things when they talk about believing in Einstein's relativity, and they're all in a mess, all in a conflict mess. So let's go back to the talk. This is where he's just Dr. Mike Young is going to explain his views on time, and time is messed up, and so he's going to mess it up.
Flow of time is totally different. Mm-hmm. And this is what I call the first bizarre consequence of our modern physics.
First bizarre consequence, and really by bizarre you mean it's messed up. Time has now been messed up by Einstein and is continuing to be messed up by these people who believe in Einstein's relativity.
That time is relative.
Mm-hmm. Messed up.
So the kid on the spaceship will actually just be turning one.
Just turning one.
One.
Oh yeah. Yes, again, these are not just weak batteries. The spaceship comes back to Earth and lands and said, oh, I get to meet my twin brother. And so out comes the twin brother who's now 20 to meet his toddler twin who is 2. Time is a lot different than you have been exposed to so far in our science and in our physics. Time is relative. Now, I will point out, notice then that time went forward. Some people get the wrong impression of this, like, oh yeah, so I'll take my spaceship, I'll go out, I'll come back before I was born. I don't know, shoot my mother and I never get born. There's some weird science fiction stories, all kinds of weird things.
Yeah, weird stuff, and this is where one of the areas they get messed up. All these people who believe in Einstein's relativity will say lots of weird things, and it will be in conflict.
That was possible, right? Time went forward. Time did not go back. This was not time travel going backwards, changing the past to affect the future. That was probably a bad example. Maybe I should shoot my arch enemy's mother. There we go. Then they'll never be born. Make you feel better. Okay. All right. But time went forward for everybody involved, regardless of what it is. Here's a nice phrase to keep in mind. Moving clocks run slow. That's the way I like to think of it. It helps me keep it together, proper time in my mind that, hey, if I have a clock that's moving, it's running slow. And again, it's not running slow because the batteries are weak. Time is not a human invention. Time is...
So he's saying time is not a human invention, but what you've got is Newton's way of dealing with time, and then suddenly Einstein wants to deal with time differently. And why is that? Why is there a change? And people like this don't really go into that. They just mess it up. There's no coherent reason for why to treat time differently.
Part of nature. How long does it take for the Earth to go around the sun? That is time. How long does it take for the electron to orbit around an atom? That is time. When we build an instrument out of it, like a watch, to measure time, yeah, that's a human design and a human invention. But time is there. Time is something that takes place outside of human perspective. If there's no humans, there's still time. Just like if there's no humans, there's still distance.
Well, the trouble is there's a thing called philosophy of science, and they all start getting weird, these philosophers, when they're talking about things. And Einstein created a great deal of change, and so when it comes to is there a reality when you don't look at it, they all end up confused. And so this person has given his point of view on it.
There's a distance between the sun and the Earth. There's a time it takes for the Earth to go around the sun, humans or not.
Which one was the proper time in the spaceship?
Good. It does get difficult because so many different, everybody has their own time now. And so the short answer is, look at where the clock is. Okay? That clock is going to be measuring, if there's no motion between that, you, the observer, and that clock, that's proper time.
So, because you said that they were celebrating up there,
Mm-hmm.
so they were the proper time. And so then here's longer because we're dividing by gamma?
So, okay, so proper time would be, say, 1 year. And then gamma, I'm going so fast that gamma is equal to 10.
Why would gamma be 10? Oh, because we said to go up 1 over a small number.
Right,
Okay.
right. So gamma is always greater than 1 and could be big, like 10, if whatever speed is needed to make it a 10. And so the non-proper time is 10 years. Here's the paradox, though. Well, we've never had twins separated at birth going close to the speed of light.
So there you go. So they're talking about this twin paradox, and they never really actually done the experiment, and he omitted it. So all this stuff is just theoretical nonsense. So when it comes down to the conflict of what all these people are saying about the twin paradox, they haven't actually done the experiment. It's all this theoretical nonsense, and they're all saying different things. So back to this again.
But another good experiment, well, I'll mention it nonetheless. A real good one is Earth and cosmic rays. When the cosmic rays come in and hit the upper atmosphere, they create radioactive particles. Call them pions. They don't live very long. So, as they come in towards the surface of the Earth, the first response is they're not going to live very long. Even if they were to travel as fast as the speed of light, they would only go a couple of miles and they would never get down to the surface. So you and I down here on the surface, we've got nothing to worry about, right? Except they're moving. So what happens to their clock as they move? especially as they get close to the speed of light. It runs slower. So you would have thought, hey, they're not going to make it, they don't live very long. But according to their clock, they don't think they live very long. But you do, and so guess what happens? They come all the way down to the surface of the Earth, and we detect this radiation, and that explains a lot of what we didn't really understand. How in the world could these crazy things get down here? And it was because their time is different.
Which is right nonsense, basically. I've got this video here which goes into it a bit more. John Chappell explains what they've done, just messed up the maths. So when they're making these claims, they're just having the maths messed up, claiming that sort of Dr. Mike Young is claiming that effect, but really what they've got is just messed up maths.
Than our time, and they do get down here. In fact, more of them get to a mid-range than all the way down to the ground. So fortunately, very few of them get down to the ground. But people who spend a lot of time in planes, like pilots and I was going to say stewardess, but what's the modern word? Flight attendant, thank you. Flight attendant. They keep track of how many hours they are up there because they get heavy exposure to radiation over a career. Yeah.
According to that equation, though, like photons travel at the speed of light. When something travels at the speed of light, time is infinite.
Right, okay, so if I was watching a photon go across here, maybe it would take 30 milliseconds, or not even that. Well, what's it, one nanosecond a foot. So maybe we're looking at 40 nanoseconds. All right, so if I were to put this into this equation, my time watching that is 40 nanoseconds. How fast do they travel? So infinite times zero. Perfect.
Which is nonsense. That equation is absolute nonsense. Infinity times zero, that is not a defined equation, defined mathematically. So you've got gamma times delta t, t subscript p, which is p for proper, and you're so getting this time interval 0 there connected to that time interval 40 nanoseconds, and you're using infinity, and that is absolute nonsense. So they got that in the maths. They're just doing mathematical nonsense. Now, to some extent, he realises that is nonsense, and he will give a bluff that they sort the maths out later. He's going to say, "Oh, it can be put down mathematically rigorously." He's going to bluff it off by saying this maths can be sorted out. So we're going to listen to his little bluff now.
Right?
They're laughing because that's nonsense.
Now, obviously, there's a little more that needs to be going on here. We've got some limits, but you can do the L'Hopital's rule or the hospital rule of your calculus and take the limit and see that this is well defined.
Well defined. So despite that infinity times 0 being nonsense, he says he's claiming he can sort the maths out and have it well defined.
And we will get the idea that, from my perspective, it took 40 nanoseconds. From the photon's perspective, it took 0 seconds. No time. And so from the photon's perspective...
So he's from the perspective of the photon, it's 0 time. So if the photon, if you had an observer moving with the speed of light, it takes no time, according to him.
Perspective, it does not evolve. It doesn't change. There's no time going on, which that alone sounds pretty bizarre.
No time going on, which sounds pretty bizarre. So he just talked a load of nonsense there. And if you notice, he's got this thing about proper time, and he's got this time interval 0 here, connected to a time interval 40 nanoseconds here. All he's doing is just nonsense. He's just done a load of nonsense. and even in the context of people who believe in Einstein's relativity, they're not necessarily going to believe that sort of nonsense just given you there. It was just all absolute nonsense. So we're going to go to what Richard Wolfson says, and it's going to point out what's going on here.
There's two things wrong with that. It's probably grammatically incorrect. It should say slowly. But much more profoundly, it's simply not relativistically correct. And I'd like you to pause right now, turn off your VCR, turn off your cassette player for just a minute, and think about what is wrong with the statement, moving clocks run slow.
So Richard here is pointing out the phrase moving clocks run slow causes problems. And that's the sort of phrase this person is using.
Why is that statement not relativistically correct? Think about that for a few minutes.
Yep.
When you're done thinking about it, start up again and we'll continue.
Not relativistically correct,
So what's wrong?
according to Richard here. So what happens is Einstein's changed all the stuff about time, and it's totally confused this poor person. It's totally confused him. Einstein has messed up time, and it's totally confused things, and it's gone through his little head, and he's tried to make sense of it, and he's come up with saying things like moving clocks run slow, if you travel at the speed of light, time is zero, which is there, and that maths there, which is nonsense. He's got that, zero. So he's saying that, and it's all nonsense. It's all gone into his little head, and it's all nonsense. So Mike Young is talking absolute nonsense from a belief in Einstein's relativity.
With the statement, moving clocks run slow. It implies there's something special about motion, special about movement, that there's somebody who's not moving, for whom the clock is right and doesn't run slow, and somebody else for whom, because they're moving, the clock runs slow. Nonsense. Nobody can say, I'm moving and you're not, or you're moving and I'm not. That's the whole point of relativity. Moving clocks run slow is an absurd statement.
And moving clocks run slow is an absurd statement, and that's the way he thinks about it. So straight away there's a conflict between the way he thinks about Einstein's relativity and how Richard here is thinking about relativity. They're in conflict.
It's nevertheless used very commonly, including in physics books or books for non-science people about relativity, to describe this phenomenon of time dilation. One problem with the idea of moving clocks run slow is you might imagine yourself in a spacecraft whizzing past Earth with a clock. That's a moving clock, right? And the moving clock runs slow. So you might imagine, in your frame of reference, everything seems to have slowed down. You watch the hands of your clock creeping slowly, every heartbeat slow. Nonsense! That frame of reference is just as good a frame of reference for doing physics in as any other frame of reference. Things have to seem perfectly normal in that.
So there you go. I'll pick that up again.
Slowly, every heartbeat.
So that was what Dr. Young here was dealing with. He was dealing with moving clocks in your spaceship with a clock, and you're moving at the speed of light. And he thinks time stops. You think we got here, time stops at zero, which is nonsense. Go back to it. So he's and he's making the mickey out of people who believe that sort of thing.
Sense. That frame of reference is just as good a frame of reference for doing physics in as any other frame of reference. Things have to seem perfectly normal in that frame of reference. If they didn't seem perfectly normal in that frame of reference, physics would be somehow different there. And the whole point of relativity is the laws that govern physical reality don't depend on your state of motion. They're the same for all observers in uniform motion.
So, according to him, Dr. Mike Young has totally messed it up just then. Total mess up from him. But I suppose you could take a point of view where they've all messed it up. All these people who believe in Einstein's relativity, they've just messed it up. They would say things that are in conflict. And you go back to Einstein, well, he just messed it up. If you try to make sense of what Einstein's saying, he seems to change his mind a lot.
What? Well, I don't know if you call that forever or nothing, because what's zero time? Let me time doesn't evolve for them.
There you go. If you're moving at the speed of light, he thinks time is stopped.
My time were to stand still, my heart would stop, my brain function would stop, my emotions would stop.
That's what the photon would see us, right?
Yeah.
And if you could be on the photon, you would see us stop.
Right.
Whoa. That's the vacation.
He's spiraling away there. He thinks, oh, this is amusing. I've told him some bullshit. He thinks time stops. And this person has pointed out it's nonsense to say that. To say that time slows down when you're moving. It's just nonsense.
All right. So you see, this is bizarre, and this is just the first of three. Hopefully, we'll get to before Dave's over.
Bizarre. Nonsense. Bizarre and nonsense must mean the same thing.
Ah, yeah.
Sorry. Does masses actually do that, not with kids though? But they said
Yeah.
that they would come back younger.
Yeah, the kid came back younger. Remember? So the kid went out. So the kid on Earth is the twin. I guess I did 10. The kid on Earth, the twin on Earth is 20. The toddler is on the spaceship.
Oh, okay.
Right, right. Yeah.
That's back to the twin paradox again, and this is where they talk their nonsense. It's a real open challenges. They've all got their different types of nonsense they want to talk about the twin paradox.
And that's actually where I was starting to go with this. You said something about twins. No, we haven't done this with humans, but we can do this with subatomic particles that have radioactive lifetimes. And these do check out to be absolutely fine. So
No, we just messed up the maths, and I pointed that out. John Chappell pointed that out. John Chappell on this one goes through the maths, and he explains all they've done is messed up the maths. So it's absurdity, bizarre, nonsense, messed up maths. People who believe in Einstein's relativity having conflict. One would say one thing and one would say something else, and that's what it is. This is Einstein's relativity. It's just a mess. And what does Einstein do? He just makes a mess. He makes this change in how you're supposed to deal with time from Newton, and it just gets all messed up. If you go to Einstein to try to sort the mess out, well, we read Einstein and he just keeps changing his mind. Einstein doesn't understand what he's talking about. I even got a video on that where Dr. Teller listened to one of Einstein's talks and realised that Einstein didn't know what he was talking about. And this is the problem. Physics has been completely messed up by Einstein.
despite how bizarre it does seem, it explains a lot of what we observe that could not be explained with Newtonian.
Which is a lie. We've already had in this mass here, we've had it explained to us how time is being treated in Newtonian physics, and how suddenly this change is made of treating it differently by Einstein. Well, we don't have to make that mess of treating time differently. We can just carry on with the maths as how Newton would deal with it. There is no reason for the change.
Physics. And so that's how modern physics works. I mean, let me take you back 2,000 years ago. To me, this is just bizarre, as probably someday people will be talking about.
So he's saying it's bizarre, which is I've taken now as to mean it's just nonsense. And if the human race survives in 100 and so years from now into distant future, they will look back to us, and if they manage to sort out what physics is, they can look back and say, what are these people saying? People like this, they're just talking absolute nonsense. Hopefully.
But when Aristotle stood up in front of the Greeks and said, you know what, this rock weighs 10 times more than this one. So if I drop it, doesn't it seem...
So what's he going to do now? He's going to mess up about this change in physics from how Aristotle used to deal with physics to how Galileo deals with physics. He's just going to totally mess up that. This is his version of the change that will happen with that, and it's going to be a total mess up. So when you consider two objects that are falling, Aristotle dealt with it a certain way and Galileo dealt with it a certain way. So we'll go back to that. two rocks.
With this, you said something about twins. No, we haven't done this with humans,
Yep.
but we can do this with subatomic particles
Which is a
that
lie,
have
all
radioactive
nonsense,
lifetimes.
all messed
and
up
these
maths.
do check out to be absolutely fine. So, despite how bizarre it does seem, it explains a lot of
just
what we
nonsense.
observe that could not be explained with Newtonian physics.
Right.
And so that's how modern physics works. I mean, let me take you back 2,000 years ago. To me, this is just bizarre as probably someday people will be talking about time. But when Aristotle stood up in front of the Greeks and said, you know what, this rock weighs 10 times more than this one.
Aristotle probably never did that.
So if I drop it, doesn't it seem reasonable that this would fall 10 times faster? Well, Aristotle said it must be true. Everybody believed it for 2,000 years. Finally, Galileo gets up there and he gets on top of the Leaning Tower. I don't think it was leaning by then, but Tower of Pisa. And
It's doubtful whether Galileo actually did this with the Leaning Tower thing. So what you got here is this person's mythological representation of science. But if you of science history, I mean, so it's to concentrate on the experiment details itself. If you've got two objects and you're dropping them, what does Aristotle physics claim about that as compared to Galileo's physics?
he goes, here's a rock 10 times heavier than this one, and I'm going to drop it. Now, what did Aristotle say? 10 times faster, right? Nope. They hit the same. Don't believe me? I'll drop it again. So he goes down, picks it up, he drops it again. Now, you can either believe what really happened, or you can put him in jail, which they put him in jail. So,
Yeah, they put Galileo in jail, basically, when Galileo went before the Inquisition and had to confess his sins, and Galileo was then put under house arrest. So his house became a sort of his jail sort of thing.
that's where we are. We are at a place that this is what seems to be really happening. You can either accept...
So it's nonsense, really. You just talk nonsense about Aristotle and Galileo. If we get into that, it's not as simple as the way he presented it about Aristotle and Galileo. With Aristotle, you had a complete way of thinking about things. If you were, according to Aristotle and the people who worked on that sort of idea of physics, things like a vacuum or a void did not exist. And so you were thinking in that sort of context. And so if you were, say, dropping two objects at normal height, say a stone, a heavy stone and a feather, well, the stone would immediately fall to the ground, but the feather might float around in the air, blown around by the air. And so it wasn't really, so things didn't fall at the same rate. But if you managed to get an object to two fairly solid objects which wouldn't float around in the air, a ball of a certain weight and another ball even heavier, and you drop both of them from a greater distance, then it would become more apparent that they would be falling to the ground at approximately the same rate, and air resistance wouldn't become significant. So what you've got is a conflict between the two ways of thinking about things. In Galileo point of view, you would be accepting the existence of, say, something like a vacuum, but from Aristotle you wouldn't be accepting that, and so your whole description in Aristotle would not be the same as what Galileo was using. It became more convenient to talk about such things as vacuum existing, and so then this change was made to Galileo. And so that's basically the change here. But when you've on to Einstein, what you've got is just a bit of maths here, and this is back to the equation here. So you've got Newton, who would be dealing with that time out there as being the same as that time in here, and so you wouldn't have any variation in time between observers. but Einstein decides that time and that time will be different, and he's gone through all the derivation here and come up with all his manipulation, and he's saying, well, that's messed up time. Time should not be dealt with that being that time being different to that time. The way we deal with time is to keep that and that the same. So it's not the same. It's no way connected to the difference between what Aristotle was talking about and what Galileo was talking about. All we got was Einstein is messing up the maths. So that's where it ends here now. Thank you.